Okay, let's go ahead and get started. Thanks everybody for joining our webinar this afternoon. It's Omnichannel Retail, Enhance Customer Experiences and Make Your Data Work in Real Time. My name is Laura Blewett. I'm the Marketing Manager for Industry Solutions for the retail industry. And I'm here with Prashant Judakonda today, our Principal for Retail Industry Solutions in the Americas, who's going to be giving us our presentation today. Prashant has been working with data and database technology for more than 30 years, and he focuses on the retail industry solutions at Mongo. Prior to joining us, he worked at IBM as a product manager for several database technologies and appliances and various technical roles at IBM R&D Lab. At Tata Consultancy Services Canada, Prashant led the data practice for the Canadian geography, and he's an experienced enterprise data architect delivering large data projects for clients on behalf of global systems integrators. We're so happy to have you here today, Prashant. Thank you for presenting. And I'm just going to go through a couple of housekeeping items before we start the presentation. So you are all placed in a listen-only mode. This webinar will be recorded, and we'll share that with you after it's ready. You are all on mute, so if you do have questions that come up throughout the presentation, just put them in the Q&A box and we'll get to them at the end of the presentation. If you do have any technical difficulties, go into the chat function and I will help you out. Okay, take it away, Prashant. Thank you.
Thank you, Laura. Welcome, everyone. My name is Prashant. As Laura indicated, this is a brief agenda. So we will be covering many topics today as part of this presentation, but then predominantly we'll focus on the retail industry, omni-channel, what it means, and then with the changes that are coming up in the industry, such as Google Chrome taking away the third-party cookies. How are you beginning to establish your domain for the customer data? And also that the customer singularity, this is something that I wanted to go into a little bit more. Essentially, what it means to have a visibility into customer preferences and in various other aspects of the customer, not only from an individual perspective, but the household, the demographics, the history, the kind of inventory that is moving in a particular area and things like that. And then when you are moving from a traditional environment to the newer modern database architectures and also modern technologies such as cloud-based solutions, what is the right approach to think about? What is that you need to be thinking about in terms of capabilities that one needs to have? And if pandemic isn't any example, then you will know that pivoting the business very quickly is going to be really important. So data mesh is an architectural approach. Let's get into that a little bit and then look at how using the real-time data to achieve the seamless customer experiences and the role of data mesh and then MACH principles will come into play. That is something that we will go into. And then we'll go into exactly, what MongoDB, how does MongoDB help you accomplish these things? I don't want to talk about MongoDB exclusively. I want to talk about general concepts and then give you the information that you need to be aware of, irrespective of whether you're using the MongoDB today or not. But think about your required capabilities in terms of what you must have in play or in place to be able to accomplish this omni-channel experience for your customers. With that, let's jump into what is omni-channel. Before we get into more details, let's first understand and define what the omni-channel is. And many of you, I'm sure, are quite familiar with this term and are living and breathing this term every day. But then the ultimate goal of omni-channel for a retailer is to be able to provide a seamless and integrated shopping experience across their multiple channels. Whether it is brick and mortar store or online e-commerce platform or marketplaces where you may be loading up some of this information onto social media and then different marketplaces, and as well as, you may have as a retailer, there may be a specific mobile app you are asking customers to download and then use it. How does Prashant, who is using the mobile phone, shopping for certain items, can be visible when he goes into the store to be able to figure that out? What is the infrastructure required? How do you need to combine this data point, these different touch points to be able to create that seamless experience is one of the important aspects of omnichannel, right? And then customer singularity. The reason why I wanted to bring in this topic along with omnichannel is that in order to provide a good omnichannel experience to a customer or a family, a customer's family, singularity, customer singularity. I mean, is this the same Prashant who is actually shopping on e-commerce website who walked into the store? These are some of the things that a single customer singularity will cover. So in omni-channel, it refers to an ability of a retailer to highly personalize and tailored shopping experience to each and every individual customer across their channels, right? This is one of the key things that we will be focusing a little bit more on. And then, what are some of the issues that actually prevent retailers from getting to that point? And then what enables this kind of omni-channel experience? So initially, let's look at, what do you need to be able to create this omni-channel experience for your customer or customers, right? So whether it is here you can actually see whether it is an e-commerce website or brick and mortar shop that you walk in or a pop-up store, if that is your game that you established, can you recognize the customer inflow? And then you have social media. Someone's comments about some things about your store in social media. Do you have an ability to address those concerns? Or you received a praise for a particular product that is being sold in a particular e-commerce website that you have. Do you have an ability to acquire that information and then act with that intelligence on things that you can do in the near future, right? So there are so many aspects to this that we need to think about. And then subsequently, you have the mobile applications from which, the first thing, at least in my experience, what I do is that before I buy something, I wanted to buy a particular motorcycle part, I will go online and then take a look at it. When I go to the store, when I see a particular item, I check on my mobile phone to see, what is the reviews on this particular product? Is it good? Does it fit to my, fit to my requirements that I have for my specific brand of motorcycle or whatever the case may be? So mobile becomes very, very important. Do you have a mobile application? Does that mobile application take all the data that is available about a customer into consideration? Can it use that intelligence or that information to create some intelligence recommendations to the customer? There are so many aspects that are associated with that. So in order for us to do any of that, forget all of them, but any of them, what you really need is, real-time accessibility to the operational data. Does the part that the customer is looking for is available in the inventory in this particular store or online, or is it available to be shipped from my warehouse if it is an e-commerce website, someone is ordering that? So the real-time accessibility of the inventory data, operational data in terms of supply chain is when is the shipment coming in? When can I actually promise the customers to get this product delivered? Things of that nature are going to be extremely important. Not only that, when a customer orders a particular item from the e-commerce website, would they be able to track that information to say that when is it going to come in? Is it in the transit or is it going to take a little bit of time? So providing those updates becomes very, very interesting and important because we all know expectations for us as customers is continuing to keep on growing, right? And then the next one would be the single view of operational data. This is one of the very important aspects. Right now, if a e-commerce website has sold out all the inventory, but then in stores, we have several of these same items are sitting on the shelf because nobody in that particular geographic region is being able to, buy those things for whatever reason, right? So a single view of your inventory across your channels is going to become very, very important. I'm just taking an example of inventory, but this could be the same thing for a product catalog. The products that are sold in each one of the stores could be completely different from one another. But then inventory details would be a consolidated inventory of your entire enterprise, will be a consolidation of all of that data. Do you have a single view of that operational data, whether it is inventory, product catalog, or suppliers, or different companies which actually deliver your goods to the end customer, the last mile providers? So that becomes really key, important aspect for anyone to start looking into that information, to access that, and then you make decisions on that. The next one would be operational and historical data availability. Like, for example, what is the propensity for a customer to buy this recommended product based on the purchase history? What was he buying? Was Prashant buying something like a golf club? And then would he be able to use a pair of shoes, golf shoes? So I need to have the transactional history of a given customer to be able to predict what they may be buying or what is the demand that's happening in the marketplace. If 100 people from a particular geographic region is buying, snow showers, there is a good possibility that there may be snowing or snow is in the forecast. So you need to have both operational data and historical data available to you to be able to feed that into a machine learning model to come up with what would be a good price point that I need to create. So things of that nature. And then subsequently, you have in-app analytics. If, what kind of expectations that customer have in terms of delivery of a given product. I come to the store and order a refrigerator. Do I have information, the operational data of all my delivery truck drivers information available to me to be able to say that, Prashant, your refrigerator would be delivered in the next, 5 hours or 5 days or 5 weeks. So in-app analytics requires, there are analytical processing that you can do within applications that will allow you to give a greater information to the customer for them to be able to enhance their experience. And then so on and so forth. So, next is the robust and flexible application stack. Is your application capable of taking changes very, very quickly? Does your data structure allow you to be able to add new attributes to your data structure so that you can actually make them available to your applications, to the end customers? Like, for example, now you begin to track that Prashant not only shops in this particular location, there are other locations he shops to. Can you take that information, give it to the marketing engine and say that, Prashant, if you wanted to go, if you're in this area, there's an item that you can pick up on sale that you're interested in and things like that. Can you do that? So flexible, available, now all this data infrastructure must be flexible to be able to say that, do I need to dedicate a DBA, database administrator, to back up this data and then save it, keep it for the recovery times if there is something goes wrong. So it must be reliable. It must be always be available because you cannot afford an e-commerce website to go down more than, you can't afford to make it go down. You can't afford any downtime there, right? And then it must be supportable that when you make changes, you should be able to easily, deploy new changes to your infrastructure and fix a problem in your application or fix a particular issue that is coming up, or enhance the features and functionality of your applications. Now, in order for you to create omnichannel experience, you need all these type of requirements. But then what are some of the challenges that we see here, right? Omnichannel is always a data engineering challenge. It's actually, you have so many different items of data that is sitting in distinct areas of your businesses that sit in, whether it is e-commerce transactional data that you need, or you need the payment information, or how many times that a particular customer is returned and what item is returned, which item is actually faulty that is completely, keeps getting returned back. Which location is this happening? So there are so many pieces of the data that is very important that need to be accessible. So the challenges typically are like data silos. Data, each one of these systems may be using a distinct and different database, right? And it is all in order for me to process returns, I may need to get the transaction history, and then I need to look at logistics and order history, when is it going to be returned, and then subsequently I may be able to issue a returns payment to the customer, right? So then you have majority of these systems for legacy retailers are sitting on relational database management systems. Or, I have seen several mainframe systems that are still supporting the day-to-day operations of a retailer. Then you have the data quality, because the data is being moved from one location, one system to the other system to be able to do certain things. Or all these systems may be pumping in their data into an enterprise data warehouse, which is used for ensuring certain things. So data quality becomes a real big challenge here that essentially creates either delays in your reaction to be able to do certain things, because you need to move the data and then you need to requalify that data, making sure that everything is in order. and then subsequently take some actions. Then the privacy and security, another big one, because now when you're moving the data from one system to the other, is your ETL secure? Is your data, are we moving it through database connectivity, or there are file extracts that are happening that you're sending in? So privacy and security becomes a big issue. Then subsequently, the governance, a retailer A buys retailer B, and now two systems are completely distinct and different. One is using Hadoop system, another one is using Oracle Exadata, the third one is using Microsoft SQL Server. Some of these things do not, when you're moving the data together, the governance of data, interoperability of the data, these are some of the areas that becomes very interesting challenges. One of the systems may be already adopted cloud, the other one is on-prem. How do you make sure that you reconcile information across those two? I personally have gone through some of those pains. The last one is the compliance. Compliance is that you must keep 7 years worth of data, transactional data available for you to, any disputes come and stuff like that. So these are the typical omni-channel challenges that a retailer deals with. I'm not saying that all of these are the challenges that they experience. It could be one or the other. It could be, a retailer experiencing the data silo issue. The other one is experiencing ability to roll out changes quickly because their DDL change is so strict that the change requests that will come in will take 3 to 4 weeks. Like if you wanted to make any change to the APIs, the testing cycle is much, much longer and things of that nature, right? So now, very good. Now we know what the problems are, what the challenges are, how many different areas that one need to look at. And every retailer will be in their modernization journey, might have already dealt with some of the challenges already, but it would be hard to imagine all of them are addressed already, right? So what can you think about? What is that allows you to be able to help get past these challenges or address these challenges in a methodical manner that helps you not only address the data silos, creating the single view of your operational data and modernizing your legacy and things like that. This is where data mesh, comes into play. This is what is data mesh and how it can help the omni-channel retail. We'll just go into that a little bit, right? So, Laura, I'll take a pause and see if there are any questions that could be addressed in this.
No, so far, no more questions. So you can keep going.
All right. So let's get into what is data mesh. This has been a buzzword for the past 2 to 3 years, and everyone has their own understanding of what a data mesh is, and they will come up with the way they can do things. So first, let's get into defining, understanding what it is. Data mesh is an architectural approach. It's not a physical, software, hardware infrastructure. It's basically an architecture pattern that allows you to be able to address, data infrastructure to be decoupled from your applications. One of the biggest challenges in the data or the industry, in any industry, is that rigidity of the data infrastructure. What I mean by that is that you touch a data element in your business, in an enterprise, every application that is using that data element must be tested, rewritten, tested, and then redeployed to make sure everything works fine. So data mesh architecture basically focuses on the business domains rather than technology. That means it removes the technology aspects of accomplishing certain things away by creating an architecture that actually leads to a distributed domain with specific data ownership and architecture. One line of business could be using Hadoop, another line of business could be using a NoSQL database, and the third one could be using SQL Server. But then if you follow a data mesh architecture, it really removes the need for understanding all these underlying technologies, right? So that's one of the key important aspects of adopting data mesh. And data mesh allows each bounded context. We'll go into the definition of what a bounded context is. Bounded context refers to a particular area of operation for a particular business, right? And then you begin to create quote unquote data products. Data product is nothing but it could be an extract. It could be like, for example, for customer domain, information about customers' address and things like that could be a data product, or a consolidation of the demographics of the customer could be a data product. Data product could be, it's as you define based on your requirements what it means to you, right? It's bounded by a bounded context within your business. And then it leaves the choice of storing raw and aggregated data to be determined by the individual domains. Like, for example, for a transactional operational data plane or a operational view, you may be doing a lot of analytics from there because your business does not require the historical data, because everything is in here and now. Like, most of the medical field where if you're a pharmacy and a drug that is being sold, it is very important for you to be able to keep track of information for the next 60 days. And after that, that data becomes useless. If it is in IoT type of scenarios, the data becomes useless within about a few minutes time because it doesn't have any value. So you can decide how you want it to store that data by business domain and what the requirements of that business domain is. And then pushes the data pipelines into each bounded context. Within the context of a particular area, you can say that I want to create data pipelines from my source systems from A to B or C to D. This is how it's going to work. And then it could be completely different. So it basically brings down, decentralizes your data movement, where you don't have to now follow a centralized ETL architecture. It could be completely different for each one of these businesses. Now, let's look into how is it different from legacy? How is it different from the way we used to do things? In legacy traditional applications, you have a mainframe or an RDBMS or a file dumps somewhere sitting in, and then your applications will be using that data, or it may require data. Mainframe data may be needed in the RDBMS, where you actually ETL this data in here as a temporary table, and then that application will use that data. Or you may create from an application that requires both the file data and as well as RDBMS data and the mainframe data. You may be extracting through an ETL or a DRDA call to the mainframe. You bring that data in and then you work with it. So essentially what happens in the legacy, traditional way of doing, everything is a direct database access, whether it is, object-related ORMs, you may be using ORMs, or you may be creating certain types of data extraction points, but you will be reaching into the database predominantly to extract your data. But what that essentially means is that whenever you make any changes to any of these systems, your application needs to be re-evaluated to make sure that it actually works. And then now with the microservices and APIs, with the MACH, where is microservices, APIs, cloud, and headless type of approach, you begin to abstract your data into API layer. Everything is from the data domain comes from APIs, right? So you want to put some data in or extract any data, you go through the API layer, and then you use microservices that will allow you to be able to say that if I want to update customer information, I'm going to use microservice customer info update, and that knows which API to use and the way that data is stored, and it will send to different databases underneath the cover. I really don't care about where it is sitting. It's the API responsibility. And then you have domain-driven design, where you begin to consolidate certain databases or data items into a particular domain, and then you use the microservices to accomplish your job. So essentially, you're abstracting your business functionality in microservices and APIs, whereas you don't really worry about what the data estate looks like, because you are now independent of that. This is where the flexibility comes into play. Combine these two is what, in microservices, APIs, and the domain-driven design, is what leads to a data mesh architecture. How are we doing for time, Laura? I think there is a lot that we need to cover, so I'm going to move quickly.
Yeah, we have about half an hour left, so yeah.
Okay, so the design evolution of data mesh, introduction of data domains. We talked about these bounded contexts, right? These are unique domain concepts. When you look at this in a customer support environment, you have the customer, you got ticket, you got defects, you got product version, and which product is they're using. that becomes a support context. And whereas the sales context is, again, you need a product and you have a territory. This is completely independent, right? This is a different domain of the sales domain. This is support domain. Now, here comes the bounded context where you actually have a common enterprise. Like, for example, the customers and product are used across multiple domains, right? So a sales domain and as well as the support domain both require these products. And this is where you begin to see the common enterprise concepts, where you can say that, hey, my domains, data domains are sales, support, product, and customer. So you begin to look at how these intersections are taking place and begin to create a common enterprise concept. And that enterprise concept is where you begin to establish a common enterprise data view. So you know that these particular data sets are used across sales, across support, across upselling, marketing campaigns, different things. If I want to sell something to Prashant, I need to know what his transactional history is and what kind of support problems he had before I say that, oh, buy another version of this. If Prashant really hates that product already because he opened so many tickets against it, should I be even sending him a message? So you begin to look at what are the common areas that I need to think about that would have influence on all these domains, and then begin to come up with the common enterprise model. And then you have the unique domain data within that domain. Within sales, the pipeline, the opportunity are completely unique to sales. There is nothing to do with the support. Support doesn't care about opportunity or pipeline. Their job is to receive the support call and then begin to work on it to give a solution to the customer, right? So you can establish by understanding your data domains and then looking at your common enterprise data elements that are used across different areas, and then unique data domains within a particular line of business or an operational department, you can begin to establish things like this, where you establish your common enterprise data and then unique data domain within those subjects. Now, data mesh refers to an enterprise data architecture that combines intentionally distributed data across distinctly defined domains, like support domain, sales domain, customer domain. These are the distinct areas. You can see that, for example, for retail, they have a customer domain and customer data product. The reason why we are calling customer as a data product is that anything to do with the customer, his address, what he bought, how many transactions he has, that becomes a data product from that comes here. And then you have PIMS, catalog, you have pricing. These are all the distinct domains that you can think of. And these are the areas like, for example, order fulfillment, management, warehouse performance, how things are happening from this particular warehouse. How many are we being able to fulfill? What is the inventory status and things of that nature? Those are the things that will come into play. Now, ubiquitous data, this term, I don't like it, but this is the definition of it. We need to, refers to the idea of making the data widely available. The customer information must be available for marketing to be able to do certain things, right? And then you also need the order data. Making sure the idea of making data widely accessible across all of the organization is what ubiquitous data means. That means, do you have an architecture that allows you to be able to make that data available? Democratization of the data is another term that people use for this. But essentially, do I have microservices and APIs that are completely cataloged to say, I want anything about the product, I want anything about the customer, I want anything about the shipping information. There are microservices or APIs that I can use to access that data. How much inventory is available of a particular type of product? Where is this product available in stores? Like, for example, when you go to a website, e-commerce website, you want to see what is available to store near me. So that's essentially is a function of something like this, making the information available to an e-commerce website about a particular store, brick and mortar environment, right? So that's what this refers to. Now, let's just get quickly into the data planes. You have operational data plane. This is the reason why I highlighted this in green is this is one of the key areas that is extremely important for retailers to really pay attention to. Analytical, you have Hadoops of the world, you have warehouses that really important. Operational data plane plays a fundamental role in data mesh architecture, ensuring the smooth functionality with the reliability, availability of the data ecosystems. That means that if there is a problem with your operational data plane, all your operations and your entire business profitability is at risk. Analytical, you can live with it. If you are not able to generate BI reports for maybe an hour or 2 hours later, that's okay. But if an e-commerce website is down, if your mobile applications are not able to receive, notifications of your orders and things like that, that becomes a real problem, right? So these are the two distinct planes, operational plane and analytical plane that are important in that domain, in the data mesh that you need to be understanding. So do I have everything that I need in my operational data plane that is available? So how now, after that introduction of that concept, let's get into real-time data availability. In order for you to do many things to enhance customer experience, real-time data availability becomes extremely important, whether it is like we talked, all this while, inventory data, sales data, promotions and marketing, how inventory is moving, which product is very popular for a given set of customers, what's happening in the weather, what is happening, historical customer data, what's been happening with this particular customer, how is she happy with the way we are operating, logistics, delivery of the goods and things like that. These are all need to be available in real time, and you need a infrastructure, data infrastructure, the data foundation that is very important for you to accomplish that. Now let's get into MongoDB. This is where it becomes very interesting. So all these requirements, challenges, what we need to accomplish that I talked about. The reason I mentioned every one of them is because every one of them is today addressed by MongoDB in a very successful manner. So, this is a quick view of how MongoDB is doing in terms of a number of clients and then employees and all the different countries where we are actually operating. And these are the sample set of retail customers that some of you may recognize your names here that are using MongoDB today to accomplish that. Now let's get into very quickly what is MongoDB Developer Data Platform. In order for us to address a range of application use cases, we talked about the inventory, we talked about e-commerce, we talked about mobile, we talked about product catalogs that need to be searched. All these things are really important. And what MongoDB Developer Data Platform does is to be able to provide a capability to accomplish those tasks with ease in this. It all revolves around the document model, key value page. These are all the capabilities that are brought into MongoDB, including transactionality. You can do asset compliant transactions with MongoDB. You have a Lucene-based search, which gives you the capabilities to search across your transactional histories and things of that nature. And then ability to provide the mobile sync automatically out of the box is some of the things that MongoDB does build all these capabilities within itself. Real-time analytics and data lake, like federated data lakes that you can put your data on an S3 bucket and then use it in combination with your database collections. That's something very important. So I can't go into every one of them, but if you are curious about any of them, please reach out to us after, and then we could be more than happy to take you into this. And then again, one of the key important aspects with MongoDB is that, do you need to learn anything different? The query API of MongoDB is so universal that these drivers, if you're using JavaScript, C#, C++, Java, any of these things, you can use the APIs or the database query API, and without even having to learn Mongo SQL or Mongo query language, you can directly start using MongoDB. So do you need to learn something different to be able to use MongoDB? The answer is no. Whatever the technology you're using, you're good to go. The other important aspect is that MongoDB Atlas is a global cloud database. You can actually establish a single database on all three cloud providers together in 100 different regions. If you are a multinational organization, and we actually have several of those customers with us today using MongoDB, some of them use different cloud providers in different regions. We can go into more details of that later. The other aspect is that serverless instances. We actually have now MongoDB is fully serverless capability. That basically means that you don't need to really think about, oh, do I need to have a sizing done so that I know exactly what my requirements are? Not really. Go with the serverless instance, and then you get all the capabilities available to instantly, from MongoDB Atlas. And then it is consumption based. It's tiered pricing. You pay only for what you use. And then it's a reliable backend foundation, always runs on the latest version. So automatically your database will be updated in the background. You don't need to really worry about, oh, do I need to think about my compatibility and then moving the upgrade? There are other aspects that go with it, which is the backward compatibility of the APIs. MongoDB always respects what you have done, so you can always continue to use your APIs the way you built them without having to worry about changing database versions underneath the cover. Right? So all of this revolves around document model. So let me take a quick pause. I think there's a Q&A that I see, Laura.
Yeah, so the question is the data lake available for on-premise MongoDB instances?
Oh, the quick answer to that one is no. Essentially, the enterprise advanced version that you use on-prem does not have the same capabilities as Atlas because of just by the nature as a data lake needs other type of storage that I don't believe is enabled for enterprise advanced, which is on-premise version. We can double check and see if there are any roadmaps that are there that that are coming up, but I don't believe so. Laura, correct me if I'm wrong.
I'm going to go with your answer, Prashant.
Okay, so now if this is a car and you need to describe it in an SQL, you have a table called seats with a car ID. There is a bodywork, there is car ID. There's an engine with a V6, V4, V12, V8, whatever. And then you have all these different parts that are represented in individual tables, and kind of, looks like this, right? This, everybody is quite familiar with this one. Anyone who used an RDBMS would be familiar with this. Now, a car in MongoDB is almost like a car. You can actually, a single document that describes the tires, the size of the tire, the pressure that is needed within the tires, the engine, the type of fuel that you use, all of them become a part of a single document that can describe the car in its entirety in one document. I'll tell you one example is that when you are going with a structure like this, right, in an RDBMS, every table will have index, and every index will be a primary key, foreign key relationship, and that's at a minimum, and you may have more. When you do a query against a database structure like this one, the database engine, however optimized it may be, will have to go in to extract the data from each one of these tables. That means two IOPS. One is an index read, one is the actual data retrieval. And then third would be a consolidation of that data in memory. So the number of IOPS that is required to access something like this is dramatically higher than a single IOP, or actually two, index and then going and pulling the data from the collection. It's a single. So one of the advantages is that cost benefits is that your ability to reduce your number of processing drops dramatically. Now you have a single collection, a single document that contains all the information that you ever need about a given entity. What is accessed in real world is stored as together. What you access in database is stored together as one entity within MongoDB collection. So that means that it is very intuitive. It's like a real world representation of the objects in the database, right? So these are some of the benefits. And then also one of the key benefits is that these documents are flexible. That means that Prashant may have 3 cars and Laura has 4 cars. So Laura's record will contain 4 distinct, car information, whereas mine contains only 3 or none. But does my collection or my record, my document needs to have all those 4 fields? Not really. It doesn't need to be. So the advantage is that tomorrow, I wanted to introduce color of the car to be tracked along with the car for Laura's cars. So Laura's, Bugatti is in red. Ferrari is in black. And if I wanted to add new attribute to this thing, this document model is tremendously powerful where, my record doesn't have any cars in it. Laura's record has 4 cars, and then including the new attributes of the color that I wanted to keep track of, I can add that, and my business functionality continues to run without any changes. Imagine this, you're making a database structural change, like a DDL change on your data, and your applications doesn't even have to be worried about it. But now you want to expand that to include that information for all customers. Now you can roll out a new API or change your query to be able to say that, okay, now the API version 2 contains the car information along with its color, and you roll it out and your application begin to use it and everything is fine. So your ability to make changes to your applications does not depend on a DBA or the data structure. It depends purely on your schedule as to when you want to do it. So that's extremely powerful in terms of that. And the other thing is that documents are universal. You want to manage and maintain the table structure, that's fine. Key value pairs, no problem. You want to have a big textual field in there or geospatial data, graphs, time series, events. JSON documents model accommodates all kinds of information in that document, and you can access it with the same query API. Now, we introduced the Atlas Data API very recently, where a uniform interface provides Atlas access, right? In seconds with an automatically generated API endpoints. API endpoints will be generated for you for the data that you need. You never have to learn anything. If you know how to use APIs, you can just go to the endpoint and say that this is my information, this is what I need, and you will get the data from MongoDB through this API calls immediately. And these are intuitive REST-like format. You don't need to learn anything new to access this. It's serverless and secure, that these APIs will run in a serverless manner. That means that you don't need to think about, oh, what infrastructure do I need to establish for this? And pagination, result shaping, these are the ones that I remember spending months and months of time. How do I do the pagination? I got 3,000 records. Oh, 3,000 is nothing. I got 300,000 records or 3 million records for my query response back. You don't need to really think about how to do the pagination. That is all taken care of by the MongoDB data API. Okay, so I got 20 more minutes or 15 minutes. I'm going to go very quickly into this one. So another very important feature of MongoDB that helps you create the data mesh architecture is not only the APIs and microservices that will be using APIs, but Atlas Search. Atlas Search is a Lucene search that is embedded with the database. And typically in enterprise data warehouse, the data foundation looks like this. You have application A using RDBMS, key value chain, Redis, cache, and then it is using Solar or Elastic as a search engine to be able to pull the information for e-commerce website, let's say, right? And then the problem is now from your data sources that are here, you're pushing the data into either enterprise data warehouse or feeding the search engine. And then you begin to make sure that your search engine is updated, and then it creates this index that you can use to be able to access your data quickly. Separate systems are required to create this search, right? So what that does is your architectural complexity goes through the roof. Now, not only you have to deal with your operational data coming from distinct systems, but also you need to think about keeping your search indexes up to date. So that by feeding the ETLing the data, from your environment into the search cluster, index it, make it available, make sure it all works and everything is good, right? And it creates the fragmentation of the developer experience because somebody needs to deal with search and another person is dealing with, a team is dealing with applications and so on and so forth. So multi-operational security models, you need to, what kind of security that I need to establish for this data, which is moving in from system A to B and things of that nature. Now, let's quickly jump into significant data integration efforts and unnecessary data duplication. These are things that we know of. So when you move the data into MongoDB, it is actually a fully integrated search engine that sits along with MongoDB. You can say that these collections, I wanted to index on these 3 fields, and it gives you full text search capability, with all the Lucene capabilities comes to you built in with the database engine. And now it is an integral part of the data platform. You don't really have to worry about, oh, do I need to, push the data into this index? No. The moment a record is inserted into your collection, the Lucene index is automatically updated. The next second, your application that is querying for that particular item will use that Lucene index, and it will bring you the data. So what we built is that in a traditional environment in the transactional DB, you actually use the ETL to move the data into the search engine, and search engine is used by applications, and they will use the search engine, get the information, go to the main database, and then get the data, even give it to the application. Whereas with MongoDB, the moment the data goes into this one, it is automatically indexed on Lucene index, and it is immediately available. Again, do we need to learn about Lucene APIs? No. You use the same database, APIs, query APIs with MongoDB, and you will have the results of the similar to what you used to enjoy with the search engine instantaneously with Mongo. I see there is a question in the chat, Laura.
Yep. So the question is, how easy is it to maintain this relationship and update a data feed with one API or microservice? Normally, microservices are built with encapsulation. This approach seems useful for analytics. For operational, it seems like an overkill.
So that is a question. If I break it down, so how easy it is that you're actually the data APIs of MongoDB could be used as part of your microservices integration. You can say that in order for me to do certain things, these are the collections that I'm using, and these collections will be used through APIs in a microservice. So you don't really actually do anything specific to create those APIs. If you're using MongoDB query APIs, that's built in, you can directly use them, right? If you're creating a functional APIs that actually require multiple data items, then that becomes a bit of a work that you need to decide. How am I going to make the information available? What APIs are there? You need to list out, categorize them, and then put them, catalog them, and say that these APIs are used for this particular domain. And these microservices are used for this particular functionality. So I'm not sure I'm answering the question, but let me quickly. How easy to maintain the relationships of that. So the relationships that you're talking about, similar to the one in a database, if that is the question, your documents are a singular entity, and that there is no more relationships unless you establish one. There is a detailed data modeling session that we can take you through, where you look at your traditional database technology and see all these relationships, and then to eliminate, we try to reduce the cross, multiple collection queries. We try to remove them altogether if we can by creating a single document version of the physical world entity, by not having to go through the relationships between the collections. But we know that that's not always possible. When you do things of that nature, then you can create an API that will access multiple collections that will help you accomplish that.
Okay, there's a follow-up as well. So product API, customer API, claims API, all these have standalone and liked one way or the other.
Indeed, you're right. I mean, from that perspective, once you look through the data model with MongoDB as compared to the original, like a traditional legacy model, you will actually see that it's going to be a significantly different way of handling that. I think I see that there's a need for a data modeling webinar, probably, Laura, that we can look into. But some of these questions will definitely be answered there, where you see that the simplicity is going to be greatly enhanced versus actually making it complex, right? So, okay, let me just quickly jump into the type of capabilities that with Atlas Search that you can get. This is, for example, if you take an example like this one, you can actually begin to see that fuzzy matching, autocomplete, right? And then not only that, you can actually begin to create facets with this database sets automatically within MongoDB. The Lucene engine will work exactly like Solar Elastic type of functionality, where you can begin to have all these capabilities with literally 3 clicks or 5 clicks. I don't remember exactly. But by choosing a select collection and then saying that I want to enable the Lucene indexing on these items, you can get these capabilities immediately, instantaneously. So that's that. I mean, once we get into, let's quickly, I just want to touch upon MongoDB data mesh, where you identify your, for retail, cash register, credit card payments being operational, then you can actually create an analytical plane with respect to what type of credit cards, this data that you have in operational data store, you can dedicate 2 shards here and say that whatever this is, these are on read-only shards, what we call read-only shards, where anything that comes into your operational data gets replicated here automatically, instantaneously. And then you can run your analytical workloads on these 2 shards without having impact anything on your operational data plane. So you can actually have a singular plane that behaves as an operational and analytical with MongoDB architecture, right? So columnar indexes, data federation, MongoDB SQL, we're actually introducing, I'm not sure if we already GA'd that, Laura, but you can actually begin to use SQL interface to MongoDB. And asymmetric nodes, where you can actually have data sets, the infrastructure dedicated for your analytics, right? This is called workload isolation, by the way. You have operational data sitting here in these shards, and they're working just fine with no analytical workload, and then that data gets replicated into these shards, where you're running crazy analytics that has table scans type of thing that you wanted to do. You can do that as well. There's compression, and then there's custom aggregation. The aggregation pipeline in MongoDB is phenomenal. Materialized views and roll-up type of applications that you're used to create can be enabled on MongoDB by aggregation frameworks, and that's a very powerful. And then I think we have several videos on this one that we can share as well. And then finally, just to wrap things up, MACH Alliance was founded in retail. MACH Alliance is about microservices, API, cloud first, and then headless. So this is the newer, retailers are beginning to adopt this in a big way. And essentially what we, MongoDB actually is certified as the quote unquote MACH enabler. By adopting MongoDB for your applications, you will be able to go towards the MACH architecture that enables you to create a data mesh, fairly quickly, versus thinking about how you create your data domains, and then now they're completely distinct. Do I need to consolidate that into a single database and things like that? Those becomes really fairly straightforward for you. All right, so in order for you to create data mesh, you need an application plane, you need an operational plane, you have analytical data plane, you have reports plane, and stream processing, which is a in-flight analytics, is becoming a very important aspect of data mesh as well, where you have an ability to do the real-time ingestion of the data and then work with it. Do some analytics on it while the data is still coming in the pipeline, right? So MongoDB has these capabilities built in, like MongoDB Realm, GraphQL, and idiomatic drivers, and the data API that I talked about will give you the capability to bring in that information very quickly. MongoDB Enterprise, which is on-prem, and Atlas is the cloud SaaS version of that one, gives you the capabilities that you need to create the single view operational data plane. There are some statistics that blew my mind. I worked 30 years in the database, and most of them is RDBMS. When I looked at MongoDB, it was like, heck, I didn't know this before. I should have known this before. But anyway, so we are able to, there is a banking transactional recent benchmark came out with 150 transactions per second, I believe, if I'm not mistaken. So the ability to do operational data on MongoDB is phenomenal for retail and as well as banking and many other industries. And MongoDB change streams is coming up very soon, and then Kafka connector. We actually, for the report plane, I did not update, but we have a Power BI and Tableau connectors that work through an SQL interface with the MongoDB. So that means you can keep your Tableaus and Looker and Power BI to work with MongoDB without any changes to the data to your application infrastructure. So finally, given all of that, this is the way that you can actually establish your MACH architecture or the data mesh using data mesh architecture. You have an application, newly designed application, which uses a data domain, different areas of data domain, whether it is operational data or the analytical data, depending on what it requires. It may go into get the historical data for using the data lake data sitting in there. So this is a much detailed slide, but I wanted to leave you with an ability to see how you can operationalize this very quickly in your environment. I never suggest to go with a big bang approach. Always pick the areas of value for you, and then experiment with it and start realizing it. And we are here to help you through this process. Last but not least, this turned over to Laura.
Yeah, thank you so much, everyone, for joining us today. And we just wanted to send you a special invite to a happy hour that we're hosting next month. If you haven't heard, MongoDB.local is returning to New York City, June 22nd, and we're having a little kickoff the night before. We're partnering up with Google Cloud and Commerce Tools to offer some kind of rooftop appetizers and drinks. It's going to be a great time. So please, I'll send out an invite link after this is over, but please do join us. If you're in New York City, we'd love to see you.
Or if you want to travel to New York City to join us, that's great too.
That too, yeah. Prashant and I will both be there, so we could say hello in person. All right, well, thank you.
Any questions, we can answer them subsequently.
Yeah. Anything else we've answered all the questions throughout the presentation, but if you have any follow-ups, just feel free to reach out, and I'll be emailing this presentation out to everybody, so you can just reply to me there. Okay, thank you, everyone. I'm going to end the webinar now. Have a great afternoon. Bye-bye.
Thank you.